Welcome to Mr. Juice chemistry class. Last time we talked about how to write formula of compound. We talked about iron 2 combines with chlorine. If it's oxidation state, you add plus here and this one becomes minus, but let's use it like this to form iron 2 chloride. If it is iron 3 combines with chlorine to form these three, as we said last time, comes here, one comes here, becomes iron 3 chloride. So take note, these three, as we said last time, is from this iron, not from chlorine. But how these numbers, how did we manage to get them? Last time we talked about hydrogen combines with oxygen to form water, H2O. 2 comes here, 1 comes here. But how did we get these states? To get these numbers, we talk about the combining power, the valencies. What you need to learn now is valency. If you know the combining powers, you will not find it difficult to write the formula of compounds. Let's look at some of the elements. If you look at the first 20 elements, 1 is hydrogen, 2 is helium, 3 is lithium, 4 is beryllium, 5 is boron, 6 is carbon, 7 nitrogen, 8 oxygen. Now let's use these ones for now. In our next lesson we'll continue with it. If you look at these ones, there is what we call duplets and what? Octet configuration. Duplet and octet configuration. In this duplet and octet configuration, we use just 2 and 8. When this shell gets filled with 2 electrons, we enter the next one. We are going to use the atomic numbers to configure it here, number of electrons, to fill it like this. Watch, look at what I'm going to do now. So hydrogen, the atomic number is 1. So we configure it as 1. The valency is 1. Helium is 2. Now this helium, this 2 is already filled. It is unreactive. We take it as 0. When it gets filled, it is unreactive. Lithium is 3. So we'll configure it as what? 2. Okay, this 3, we'll configure it as 2 and 1. We'll configure it as 2 and 1 here. 2 and 1. Then the valency is, the combining power is 1 plus 1 is 1. The plus 1 oxidation state. Then 4 is beryllium. We'll configure it 2 and 2. The combining power is plus 2. Then we look at boron, 5, 2 and 3. The combining power is what? Plus 3. We look at the next one. Carbon is 6, 2 and 4. Stability comes when you have only 2 and 8. So this one can either gain or lose 4 electrons. So it can be plus or minus. If it gains 4 electrons, it becomes 8. If it loses 4 electrons, it comes to 2, which is stability. So we can write the oxidation state or combining power as plus or minus 4. It can gain 4 electrons to become stable or lose 4 electrons to become stable. Nitrogen is 7. From this time we are getting non-metals 2 and 5. 2 and 5. So now that is above 4, we have entered non-metals. We have entered non-metals. So 5 minus 8 will give us minus 3. Then this is oxygen. oxygen 2 and 6. 6 minus 8 will give you what? Minus 2. That is why the oxidation state or the combining power of oxygen is what? 2. You can now see it. Combining power of a hydrogen is 1. So look at it now. Hydrogen 1, oxygen 2. So when they combine, as I said last time, this means that hydrogen wants to donate 1 electron, wants to donate just 1. Oxygen needs just 2. So for hydrogen to stay stably with oxygen, we need to have 2 hydrogen atoms. So hydrogen, 2 hydrogen atoms that will balance with these 2 oxygen two that oxygen needs here. That's why I write it as H2O. It is stable like this. You can write the formula of any elements, any compounds rather, using the elements. So if you can write the first 20 elements, you can configure them and then do the normal combination. When you do it like that, you will surely get it. So the assignment I'm giving you now is write the remaining 20 elements and try to combine the metals and non-metals and see what you can get. So try to do this. Give us the formula of magnesium nitride. That is when magnesium combines with oxygen. In our next class, we are going to look at this. Thank you very much.